Hey gang, here's what we're gonna do. ANCOVA. So let's talk about what the heck is ANCOVA and when and where we use ANCOVA. And then work one. So ANCOVA is halfway between ANOVA and regression. It's actually losing favor just because regression is much more powerful and we kind of have better ways to deal with this problem. But let's talk about ANCOVA because it's still an analysis you can do. So what happens in an ANCOVA, we're going to treat this in its very traditional form, is we're going to think about it as a type of analysis that is controlling for some sort of continuous variable first, and then looking at your categorical variables, predicting your dependent variable. So control first, hence the C, then ANOVA. So control, then ANOVA. And what I've kind of drawn here is this picture, which you'll get a lot more when you look at the regression section, of the variance and the DV. And we've spent all year talking about good variance and bad variance. So the CV here, or the covariate, or if you want to think about this as your control variable, accounts for some of this error here in the DV. So if you kind of ignore the CV here for a second and think about this IV, this square here would be bad variance. So we would be predicting good variance to bad variance, and then we'd have this chunk of bad variance that we didn't know what to do with. Well, that hunk of variance there is actually due to something we do understand. So it allows you to control for that first and then test your IVs. So this analysis gives you a lot more power because you're controlling for some bad variance that you understand what it is due to noise variables or nuisance variables or just confounding issues. So this is a good thing because it allows me to control for some problematic variance. Now, what are all these definitions? So the CV is the covariate. This is the variable that changes with the dependent variable. It's used to adjust the dependent variable to sort of deal with bad variance. So CVs can be continuous or dichotomous, usually continuous. They're used to adjust the value of the dependent variable to create larger group differences on your independent variable because it is controlling for bad variance. Really, your CV needs to be related to your DV. If your CV and your DV are uncorrelated, this is a waste of your time. IVs are independent variable, and in this particular case, since it's still a ANOVA family, it needs to be dichotomous, right? Or not even dichotomous. It needs to be categorical. So that's a bad word choice there. It works better if they're just categorical. So we can put people into groups or your experimental manipulations. And your dependent variable need to be contiguous, or you might need to do log regression. Okay, how is ANOVA related to other things? ANCOVA, it's a type of ANOVA with control. So ANOVA is regression, a special type of regression. So it's kind of fair to say that ANCOVA is sort of like halfway between regression types. So if you use this section and your hierarchical regression section, you'll see a whole lot of overlap between the two because they have a similar type of feel. So what happens first is the variance between the CV and the DV is analyzed, and it adjusts the DV to not include the CV variance. And that's like similar to a hierarchical regression, controlling for that CV, especially if it's continuous. Then you do a regular ANOVA on those adjusted means. So you'll see the word adjusted scores or adjusted means a lot. So therefore, kind of a big summary of our entire ANOVA section is if this is a between subjects design only, you would interpret Levine's, and you would probably pick an independent Ttest or a between subjects ANCOVA on the adjusted mean, and you might pick Tukey as your correction. You could also pick Bonferroni. Repeated measures design, you would use Mockley's test, and then your post hoc test would be dependent T or repeated measures ANCOVA on the adjusted means, and could still use Tukey or Bonferroni. If you got a mixed design, you're going to do both Levine's and Mockley's, and that post hoc test correction combination depends on your split. So kind of give you the same chart that we looked at when we did ANOVA. And so if there's a main effect between, and there's more than two levels, this is a summary of what I just said. Independent T, Tukey, if it's a main effect repeated. right? Dependent, Tukey. If levels are only 2, remember you just interpret the mean scores. For that interaction, we're going to split one of those IV columns, and then it depends on the split. So this is like our mixed ANOVA that we just finished. And remember that if the interaction is significant, people will ignore the main effects because it reduces type 1 error, and like, why are you doing main effects if you're only concerned if the whole point was to do the interaction anyway. So kind of new to this section, we're going to use those adjusted means to calculate effect sizes and post hoc tests. So we will delete this bad boy, and you guys already know all this stuff. So basically it's just about adjusted means. Sorry, that's relevant to the R people. So some quick notes on assumptions. It's accuracy, missing, outliers, all the same. But for outliers, we want to also look at the CV. So the CV and the DV this time. And I would say, like, if they have an outlier on one, you can decide if you want to eliminate them. But if they have an outlier on both, get rid of those bad boys. For additivity, we haven't discussed additivity with ANOVA yet, but for additivity, if I only have one CV, totally not necessary. If I have 2 or more CVs, we want to make sure that those 2 things don't overlap. And the rule's a little different here. It's 0.7 instead of 0.9. But essentially the problem is with highly correlated CVs, you're just losing power by using the same variable twice. So we only want to use variables that are different, so they're controlling for different parts of the DV variance, not to use variables that are the same, because then we're wasting our time. Linearity is pretty important because that's the way that it calculates the relationship between the CV and the DV, so we need them to be related, and we can use our QQ, sometimes called a PP plot, depending on which section we're working on. Those are the same idea. We want our CV and our DV to be normally distributed, so we're going to run that fake regression and look at the histogram of the residuals. Homogeneity, we can use our residual plot from our fake regression. And Levine's test, also kind of looking at sporicity, so that's a different type of equal variances. And homoscedasticity, we do not want megaphone shapes, so we're going to look at our residual plot from our fake regression. So in this particular analysis, we're going to do an all between analysis. And I don't really have any comments on repeated measures here because this is actually a little easier in JASP. But we're going to do all between. And we looked at their attitudes towards the use of drugs to see if there are group differences in attitudes about drug usage. And we're going to control for physical health symptoms because people who report more symptoms, physical health symptoms, are going to have more positive attitudes about drugs because they're sick. And so if you are ill and those drugs are helping you, potentially you're going to be more positive because those drugs are helping you. It also might be that there's no effect because the drugs don't help. So we're going to control for that first because we know it's a nuisance variable. And then we're going to look at employment status, since employment status might have a lot to do with health insurance and religion, and look at those differences in that interaction. Okay. So our employment status is employed versus unemployed. Our religion is 4 different options here. I know there are more options in the world, but these are the 4 in that data set. Our control variable is physical health. So higher scores are bad, so that means you have more health problems. And then attitudes towards drugs where higher scores are more positive. Okay. So let's start where we always start, which is power. Okay. So we're going to click on Ttest. Our statistical test type here is ANCOVA. Fixed effects, main effects, interactions. It's the only ANCOVA option, really. So we're going to hit determine to get our effect size. Let's see, what do I do in this example? Let's do small, so 0.01. So partial a to squared, direct here is 0.01. Oops, not 0.9. Calculate transfer to main, we've got 0.05, so 0.80 for powers, the criterion we're trying to hit. And let's think about this numerator DF thing. Okay, so numerator DF for our main effects is levels -1. So it would be either 2 - 1 or 4 - 1. And then the interaction is levels minus 1 times levels minus 1. Okay. And so I calculated that here. 2 minus 1 times 4 minus 1 is 3. Even on a bad day. Our number of groups depends on what we're interested in. So we're interested in the interaction. So I'm going to do the number of conditions. That's 2 times 4. So that's 8 conditions. Our number of covariates is 1. So hit enter. It says we need 1,084 participants. Good grief. Right? So let's hope our effect isn't that small, because otherwise we are screwed, because we definitely do not have 1,000 participants. Okay. So let us scroll past all of this stuff. And I'm going to hit insert, page break here, and we will come back to Word after we're done with data screening. So let's go away GPower. Let's check out this data. All right. So we've actually got a couple of extra variables that we don't need, this mental health and psi drug. So we're going to do File, Save As, and we'll do data screening here. We're actually just going to get, yeah, that's fine. Oh, did I save that as an let's save that as a real Excel file so I don't screw that up. Oh, no, I didn't. There we go. I'm just going to get rid of these 2 variables, right? So we're interested in attitudes towards drugs, controlling for physical health, and then our 2 variables here. So I'm actually going to get rid of those 2, and I don't need the subject number unless you just really want it. So I've kind of eliminated down to only the variables I need. Okay. So we're going to save this as our master data set and get to work. So let us do... first, I'm going to check my, I'm going to check my CV and DV here for out of range data. So let's start with accuracy. Data analysis, descriptive statistics, hit OK, highlight these 2 columns, labels, summary statistics, and our scores are not out of range. So attitudes, let's say they run from 0 to 10. Physical health symptoms, and they can't be negative, right? Because I can't have negative physical health problems. So that seems to be okay. Now I do want to check these 2 columns just to make sure I don't have any extra stuff. So I'm going to highlight them and paste them into here. And then hit remove duplicates. And just make sure I don't have anything weird going on. So it does look like I have some missing data, because what it did was it actually gave me every combination of variables. So I have employed Protestant, employed Catholic, employed non, blah, blah, but then I have a blank employed. So we might want to deal with that in our missing data, but I don't have any like extra stuff going on over here. Okay, so I do have some missing combinations, but I don't have anything that is misspelled. So now that we've checked for accuracy, we can kind of tell there might be some missing data. So let's copy all the data here. Let's not erase the data, let's just copy it. And create ourselves a no missing. See what we can get calculated here. Now, sometimes the way that this copies is unfortunate at best, and I think we've had this problem kind of all year. And so there are several ways to deal with, let's see if we have any missing ones, or if it just was acting funny to act funny. Sometimes Excel does that. I don't see any missing ones. Ah, there it is. Now, you guys we've had this issue a couple of times on whether or not this cell actually has anything in it. Remember, it's caused us some issues. So let's see if when we run our missing data, if that happens. So we're going to do %valid. So do equals, count A, highlight everything. Because I'm actually interested if there are other scores over here are missing. Sometimes we don't care, but today let's care. So times 4 divided by, times divided by 4, good grief, times 100. Beep boop. So remember, white plus to black plus, double click. I'm gonna highlight everything, I'm just gonna hit sort. It tells me that everything is 100%. And I know that it's not, because I do. So I'm gonna hit filter, because I've already done a little bit of data of accuracy checks. And I'm gonna turn all this off and hit blanks. Okay, so there's 3 people that actually have some missing data here. And I don't know why Excel does this. It makes me nuts. I wish it wouldn't. So here's one solution. You can hit Control and F or Command F or click here and do replace. Either way. So if I hit Control F, okay, it only brings it up here, so I'm going to click replace over here. And I'm going to hit the space bar and tell it to replace all. And that actually told me it replaced 10 instances. So there were some other places that I had some weird spaces that I got rid of. Now that wasn't working for everybody's computer. I know, because you told me. So what you can do is use the filter command to help you find these spots. And you never would have seen them because of this weird quirk in Excel if you didn't do this. So that's why this accuracy thing is so crucial. So click filter, click on this button, and it'll show you blanks. It'll think they're blanks or that they're spaces. And then you just click in each box and hit delete. And so I want to turn all of them back on. Do the same thing for employment, just in case. I know employment's okay, but now I can really tell there's no blanks. So now let's sort. And when you click sort here, always say expand. Let's put these 3 bad boys at the top. So here's the first problem. I cannot guess at their religion. So I'm going to take these 3 and just get rid of them because I can't use them. Okay. Now when you import this into JASP, it will actually delete them for you because it won't want to use them. But if it interprets them as their own category, that would be a little weird. So let's go ahead and delete them because we know we can't use them and we can't fill this type of data in anyway. So now I have 100% valid, but we're still going to do by column. So times, oh, how many do I have? So I have 2 all the way down to beep, 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 beep. 463, so I have 462 participants at this point. You know, it's not times, it's divide. I did that twice now. Times 100. You know you've done it wrong if you get scores over 100. Just FYI. And now I have 100 in each box. So always kind of check for blanks, especially because of those weird Excel quirks. So I can actually do that in all of the columns. Click here. All right, and those hundreds are the last row, so they're all okay. All right, so we've dealt with the missing data. Let's work on outliers now. So I'm gonna highlight these 3, stick that in a outliers. On no out. So we deleted 3 people who had missing data. Let's think about outliers. So for outliers, I'm going to create a Z attitudes and a Z health. So to do that, I would do equals, open parentheses. Click on the first one, minus, type the word average, highlight everything, close, one more time, close, divided by STDEV, open parentheses, click on the everything, close, and then you're good. White plus to black plus, come on. Sometimes it does not want to let me drag and drop, like right now, for some reason. So you can also hit Control C, Control V will also work. But the reason I want to drag and drop is so I can double click right here. There it goes. It's being grumpy with me. Okay. Now 400 participants is kind of a lot. So let us highlight. So go home. And I'm going to highlight both of these. Conditional formatting. Highlight cell rules. greater than 2.99. And then conditional formatting, highlight cell rules, less than negative 2.99. Now I could scroll through these and just kind of wait and see if anything red pops up, which it does. Or we can use that same filter. So let's do data, filter. And you can actually filter by color. Well, usually you can filter by color. Okay, so there's no filter by color, which means that none of them are outliers. And if I look at the scores, I actually don't see any outliers. Right, so that column's a moot point, but health here, so see how by color is on, I can pick to show me only the rose ones. So I have 4 people at the very top of our distribution who have outliers in the number of health-related problems they have. And I have to make a decision here. Are those the people I want to exclude because their health symptoms are too high for this data set? Or are those people who are really valid health complaints that I want to leave in for the data set? Okay. And they're kind of all over the place. They're not all in one group. And in this particular case, I'm going to leave them in because their scores are valid. So when you have outliers like this, I mean, I am the queen of like delete them and move on with your life, but always think about what does it mean here to be an outlier? And there it means that they're just at the top of the distribution because there are scores up to this point as well. So they're just much higher than everyone else, but it's not like I have a huge break in the distribution. And I might go back and check, given their subject number, make sure that score is valid, if I can, right? You can always test it with and without these people as well. Okay, so for once this time, we're going to leave outliers in, okay, but you could delete them. Additivity is not an issue in this particular one because we only have one CV. So we're going to create that final data set page. And work on our assumptions. Now after this point, assumptions get a touch easier. Woohoo, party! Okay, so let's make up our random variable. So equals rand, open close parentheses. And highlight that and put it all in there. And then let's make our fake regression and work from there. So click data analysis, and this is a big data set, so this might take some time to run or it might crash and burn, but let's try it. Go to regression. Okay. Our Y variable here is all of the random data. Our X variables here are these two, and we're keeping them separate. We're not creating an average. I don't have labels, but I do want to standardize residuals and the normal probability plots. And we could turn on residual plots, but we're actually going to make our own residual plot, as you've seen me do a couple times. So let's see if we can get this to run without so many plots. We're going to wait a minute. Oh, that was quick. Oh, that was much faster. Usually that takes forever. My computer likes me today. So let's roll with it while we can. Remember, to make that histogram, we're going to create some bins here. We're going to do -2, -1.5, -1. Oops. -1, and we're going to keep going until we get to 2, and we're going to take our standardized residuals and make a histogram. So click data, click up to histogram. Our input range here is under the standardized residuals. The bin range, wherever it went, way up here, is this. I want to give myself a chart. I'm going to tell it to stick it right there. It always sticks the chart way up here, not with the rest of the stuff that you're actually interested in, but I'd say this looks okay. Right. Oops, I don't want to hold that down. So it's got a little dip here, but that's pretty centered over 0. It's between 2 and 2, so there's nothing over here at more, so it looks pretty good. Okay, so I would say that this data set is multivariate normal. Linearity is up here. Do I even need to add the line? We can add the line, but I don't even know that you would see it. Add trend line. Yeah, it's not even there. That is nice and straight. Last but not least, let's make that scatter plot for residuals. So I'm going to take my predicted Y. Just going to stick this over here. Delete that middle column. So I want a scatter plot of the, just in case you weren't sure what just happened there. Oh, good grief. I have predicted Y and my standardized residuals. So I just deleted the middle one because I don't need it. So I'll highlight both of those. Click home. I'm sorry, insert, scatter, scatter. You don't have to do a whole lot to this. So is it centered over 0? Yeah, it's pretty much from 2 to 2 out here. Is it centered this way? Yeah, it's pretty good. Yeah. It doesn't seem to have like a in proportionate amount of dots on either side. And man, it makes it like a beautiful little square. Look how square this is. Woohoo, square. So I would say homogeneity, homoscedasticity are all right, given whatever Levine's tells me. Right, so it's still an ANCOVA, so I'm still going to be looking for Levine's. I'm going to take my final data set here. Now I've kind of checked everything. Copy it. Make myself a new data set here. File, save as, and we have to save it as a CSV. Because, oh, just a regular CSV. That's what JASP imports. Now I could keep this open to do graphs, but I'm gonna kind of close Excel so my computer does not crash. And let's work with JASP here and run that analysis. Alright, so let's open some recent files. Oops, computer. Close enough. Let's go to ANCOVA here. We're going to use our final data set. Right. So to run ANCOVA, what we do is click on ANCOVA and come down here to ANCOVA. And we want to take our attitudes towards drugs as our dependent variable. Our covariate is physical health. And our two categorical variables are fixed factors. Okay, so we got our ANCOVA over here. Okay. There's kind of a lot that's going on, but we're going to click Homogeneity Tests to get Levine's test. And it's not significant, so that's good. Our homogeneity scatter plot matched our Levine's test. Woohoo! To finish running the test, I'm going to click Additional Options. I'm just going to ask it for my means, just so I have them. Can also ask it for descriptive statistics. Descriptives are nice because remember it gives you standard deviation for your effect size stuff, but also measures of effect or partial eta up here. We can ask for post hoc tests, but first we need to see if we even need to do that. So let me copy all of this and let's look at what happened, see what the next step is, which is unfortunately kind of gross, but we'll get there. So let's talk about Levine's first. So is Levine significant? Oops. Sure, why not? And I would say no. So it's degrees of freedom 7 and 454 equals 1.72. P equals 0.10. So it's not significant. Woohoo! Great. Now we have done this as a multi-way ANCOVA, so it's got a lot going on. There's more than you've seen here before. So we're always going to start with the covariate, not covariance, covariate. I think I typed covariance again. You can tell I teach a class where that's a common word here. So we're going to start with physical health symptoms. You can tell my computer's like, just stop with the videos. Okay, so for physical health, here it's 1 and 453 equals, here's our F, so 6.65, and it is significant. And I asked for eta. I meant to ask for partial. Give me partial eta squared. So let me just update this box. My fault. Okay. Partial eta squared here is 0.01. So they're not that different, which is good, but that means our variables are relatively uncorrelated. Come here, you little p. I'm going to stick that bad boy right there, which is where I've normally seen it reported. Is 0.01. Weird font changes, weird bolding, weird everything. What are you doing, computer? Stop. There we go. So our covariate is a significant adjuster of the means, but it's a small effect. Okay, so when I say it's a significant adjuster of the means, I mean they're correlated. Really, that's what it is. So one thing people will do is actually just report the correlation between, don't capitalize, our CV and our DV here. So let's run that. So I'm going to click regression, correlation. Just going to add my two variables here. Very simple. That correlation is 0.13. And so that matches with what I know about eta here. So eta is 0.01 and R is 0.13. Okay. And that implies that they're both small effects. So yes, it's a significant adjuster of the dependent variable, but it's small. Then we're going to talk about our main effects. Okay, so we're going to use F. Which one do we want to do first? Let's do employment first. So it's 1, 453 equals 0.45. Our p-value is, I keep hitting the wrong button here, equal to 0.50. I'm going to copy this eta squared so I don't have to fudge with the symbols. And eta squared is less, you can say equal in this particular case to 0.001. Oh, we want to look at partial down here, so I want to look at this number, but it's the same. Okay, and that is not significant. So after controlling for physical health symptoms, there is no relationship in between employment and attitude towards drugs. So our employment ability, sort of our health insurance capability, it's not related towards those attitudes. Now, what about religion? Oh my goodness, that is the weirdest spelling of religion ever. Okay, there we go. I'm going to copy most of this, so I don't have to reinvent the wheel here. But if you do that, make sure you watch what you're pasting. So 3 and 453, so I got to change this one. And that F is 2.55. And that p-value is close to our line in the sand. So it's actually 0.06. Eta squared partial, I'm going to come down here, is 0.02 if I round up. And so sometimes people call this marginally significant. That is a tricky spot to be in. But let's look at that interaction, see what happened there. What is it with me in the letter C? So I'm going to say that interaction is 3, 453. So I'm going to change this one. It's 6.65. Oops, I'm sorry, I'm looking at the wrong one. 2.86. I was like, I feel like I wrote that number already. Because I did. Alright, and p equals 0.04, so that's significant. Partial eta squared coming down here is again 0.2 if I round up. So that is significant. So I don't really need to mess with religion and talk about its marginal significance or not. I'm gonna do the interaction instead. This is where it becomes a miserable existence. Just like our double between subjects, if you watched that video, we now have to find a way to analyze this interaction by splitting them up. What I mean by that is I have to find a variable to split on to compare them. And there are a couple of rules that make this easier. Number one rule, which by the end of the semester you should know, is do what your advisor tells you. The second rule is to pick the way with less comparisons. Unfortunately, what that means is that there's more kind of cutting and pasting in Excel, but it does make it easier on the far end, if you will. So what we can do here is, sorry, I just had a brain fart. What we can do here is split and do all of the hard work at the beginning with Excel and then only run a couple of comparisons. So what that means is that we have a 2x4 where we have employment by, so let me make this 2x4. Right. So I have people who are actually needed to do one more for each one. Boop, boop. Whoa, don't do that. Okay, so these people are employed versus unemployed, employed. Okay. And then what we want to do is think about Catholic. What are other options? Jewish, our short list of religions here, none, and Protestant. Okay. Now I can compare across or down. So if I'm comparing down, I've got Catholic, employed versus not, Jewish, employed versus not, non-employed versus not, Protestant, employed versus not. So that's 4 comparisons. But if I'm going to go across, that's a lot more. So Catholic to Jewish, 1. Catholic to none, 2. Catholic to Protestant, 3. Jewish to none, 4. Jewish to Protestant, 5. None to Protestant, 6. Repeat that whole thing with employment. That's 12 comparisons. Blech. Okay, that's a lot more comparisons. So we're going to take the harder route and split into 4 data sets, Catholic, Jewish, none, and Protestant. So we get 4 comparisons, not 12. Okay. So by taking a little bit more time in Excel, we're dealing with less post hoc tests, which is the type 1 error saver, and just a general like typing of Ttest values saver. And so I took these means and standard deviations and ends values, and I just went ahead and plugged them in here. Okay, these numbers may be slightly different because I did not exclude outliers, and here I probably did. But we can kind of clean this up by putting it all on the same page. So I cut and pasted this from when I did this example in R. So we've got Catholic employed is 7.67. Standard deviations 0.98. These numbers are very similar. 63. Our Jewish employed, some work down, 7.60. So you see the outliers don't appear to be changing this very much. Protestants 7.51. Standard deviations 1.08. And then our none group 7.67, 1.35, and 46. Okay, it's about the same. So unemployed Catholic group is 804, 110. If I round up, 7.81, 1.21, 48. Protestant group, 7.84, 1.19, 83. And our none group, 7.10, 19, and 30. Okay. So let's calculate our p-value, our t-test. Let's do the way we normally do this. Sorry, is our test, post hoc test here. Our effect size. And we can kind of explain what happened here. Okay. Let's do the dirty work. So we've got our between subjects ANCOVA final data set. Okay. So I'm going to copy that. I'm just going to paste it 4 times. 1, 2, 3, 4. Okay. And so for this first one, I'm going to make this our Catholic group, our Jewish group, Protestant, and other, or none, I guess. And now I have to open each one and sort of clear out everybody else. Okay. So we open the Catholic one. So what I'm going to do is sort this data. So data, sort. I've got Catholic on the top. So here's a quick way to do this. Hit filter, click the button here, and I want everybody but Catholic so I can get rid of them. Highlight all of that, just right click, go away. So now I only have Catholic here. Now leave employment, both categories in here, or you're going to have a hard time running this analysis. So I'm going to close this. I hit don't save because I hit save first. Right, and that's because it's goofy. Make sure you only have Catholic in here. If you don't, when you go to run this in JASP, it'll go because you have more than 2 categories, and you'll know you've done it wrong. So now I still want to sort, and sorting just makes it a little easier. Click filter. Now I want everybody but Jewish. We're going to delete all of those. Turn that filter off, and so now it puts Jewish at the top. And sorting helps keep that kind of all together. So I hit Control S to save it, and then I closed it, and that, for some reason, will save it on my computer. So be sure you're hitting save, and it doesn't magically not exclude people. We're going to do that whole thing twice more. So once you get the hang of Excel, it goes a little faster. This is my none one, yeah. Turn that filter off. Great. Okay. So I'm just hitting preview on my Mac just to make sure. I don't think Windows totally has that option, so +1 for Macs. Data, sort. Let's get the filter. This time we want only Protestants. Right, click, delete, turn off the filter, our Protestants, close all that. All right, phew. Now, back to JASP. Let's open that data set. Catholics. Okay, so only Catholics. Now this could be a t-test. And what we're going to try to do here is sort of test what's happening in JASP real quick. So kind of on the fly here, but we really need to control. We really need to control for that covariate. So it's tempting to do a t-test because it's like independent t, right? It's a good follow-up. But that independent t will not control for that covariate. And then you've kind of wasted your time. You might as well have just started with the t-test and moved on with your life. So we're actually going to do 4 mini between subjects ANCOVAs. So I'm going to click ANCOVA. And now I want to actually run the same analysis I did a minute ago. So attitudes towards drugs are dependent variable. Physical health is our covariant. And these two fixed factors here. It contains fewer than 2 levels. Okay. And? Oh, sorry. My fault. We're going to take out religion. You only want employment. My bad. Go away. Pretend you don't see that I made that mistake. So we split by religion. So remember, you don't include the variable you split by. That's my fault. So we're going to do little one-way ANCOVAs. Okay. And we actually don't need to do anything else. So there's no post hoc test necessary. But what we can do is ask for effect size. And we could keep the whole thing in partial eta squared. Now, normally follow-up tests are D. And we could calculate D, but that would take an extra step. So as long as you have some sort of effect size, don't really care what it is. Because I don't want to have to calculate all this stuff and copy paste it and then go back and type all this back into mode. So we're just going to keep the effect size we've been working with. Okay. So this is for whichever group we started with. First, Catholics. So let's paste those here. And I'm just adding this so I know which group I did. So our post hoc test here is F. And we just copy it so it's employment only. So 1, helps if you type in the right place, 1 and 116 equals 1.41. Our p-value is 0.2424. Okay. That effect size is eta, which is, let me copy it from up here. Boop, 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 boop. So I don't have to do anything screwy. Is 1.01, or no, 0.03. Because we're looking at this line here. So it's not significant. So Catholics, employed and unemployed, do not have differences in their opinions on drugs after controlling for physical health. Let's do that now 3 more times. So if you had to ask me what I would love to see JASP do better, data screening, post hoc between subjects test. Because it does not do this well. So click ANCOVA, ANCOVA, attitudes, fixed factors are covariate, don't put religion in because it'll freak out. Click employment. Under additional options here, we're going to ask for partial eta squared, copy. Let's add this down here. That was, who did we just do? Jewish folks? And I'm going to start to close some of these so my computer doesn't have a heyday. It doesn't have a fit, basically. Don't save. So we did Jewish just now. And we do the exact same thing. So I type in my F statistics. I'm going to copy these 2 boxes and see what's different here. So I've got 1 and 89 is 3.57. P-value is 0.06. Oh, damn, it's so close. And eta squared is 0.04. So if I wanted to interpret this, what I would say is that unemployed people have a higher opinion of drugs than employed people, because the mean is bigger over here. But it's a marginal effect, so you gotta kind of be careful with that. And it's a small effect size. Alright, let's run this JASP thing twice more. Then we'll talk about charts and run away. So let's open none here. ANCOVA, same setup. Attitudes, physical health, employment. Click, click, click under additional options. Effect size, partial eta squared. Copy, copy, copy. This is our none group. Why on God's green earth? I have no idea why. Sometimes it copies weird and sometimes it doesn't. So for our none group, let's get that. Like, what are you? Whatever. I don't even know. Copy this. So for our none group, we got 1 in 73. So 173 is 3.24. Now, did I do the right F statistic? You guys. Don't do what I just did. Beep. Okay. So don't look at physical health. I actually did the wrong one. So let's fix this. So it's F is it's 1 in 89, right? And F is 0.40. Derp. Our p-value is not marginal. It's 0.53, and our eta squared is very small. Okay. So we would say this is, sorry, we would say this is not significant. Talking with a pen in my mouth. All right, now let's try our none group, and I'm just going to black this out so I don't make that same mistake twice. So it's 1 in 73 is 3.24. P-value is 0.08, which still falls in that marginal range. Marginal mostly meaning 0.05 to 0.10. And our eta squared is 0.04. Okay. If I wanted to interpret this, and that's up to you guys, the employed folks have a higher attitude towards drugs than the unemployed folks. For people who identify with none or other religions, which is kind of a broad category of people. Let's do one more. And then charts. Let's do Protestant. ANCOVA, ANCOVA, attitude, physical health, employment under fixed factor, additional option, nope, don't want that, effect size, partial eta. Copy. And this is Protestant. Do the same thing here so I don't screw this up. 1 and 172, so this is our largest group, is 3.40. P-value is 0.07. Ugh, all this stuff right on the edge. 0.02. Same issue, it's marginal. And unemployed folks have a higher attitude towards employed folks. Okay, so what does that imply? Well, none of these are really significant, and they're all very small effects. So what's happening? Well, that small effect is mirrored up here in the interaction, 87 pages up here. Right. If we go all the way back to our interaction, we see that the effect size is really small. So when we start to split that up, it's going to be hard to find anything because we found that interaction probably due to power. So we're able to find that small effect, but once you start to split everything up into the smaller data sets, you just don't have enough power to find it. Additionally, it could be that the interaction actually is the other way. It's more about the differences in employed people by religion and unemployed people by religion. So you can choose to split the other way. You're just going to need to do a lot more controlling for type 1 error, which means you'll probably get about the same effect. Now this did not control for type 1 error given these p-values because we run each ANCOVA separately, so we might need to do a little bit of controlling. I'd argue Ttest is kind of right there on that, like, not so much. But if I decided to run it the other way, definitely need to do some controlling. So that's a little bit on like post hoc testness. And the last thing we always do is graphs, everybody's favorite. So let's take those means and standard deviations that we got from our original analysis, this thing. See if we can't make ourselves a graph and call it a night. So let me go back to Excel here. All right, so we're just going to need to do a little bit of a rearranging of this data. So I'm going to put employed here, unemployed here, and then let's go cath. Actually, that's fine. It would be easier if we went the other way. It doesn't matter. Now this is alphabetical order. You could put them in any particular order you were interested in. I'm just cut and paste in here. Control C, Control X are your friend. Okay. Now let's do that same thing, remember, for the standard deviations. I don't know if it's faster to type them or not, but I just think it's much more fun to, oops, wrong button, cut and paste them. Okay, just make sure they get in the right box. Okay, now let's highlight everything and make a double bar graph. So click Data, Insert, Clustered Column Graph. Now remember, we talked a little bit before about making the graph that matches the post hoc test, so I'm going to stick with the way I have it because I broke them into these 4 categories and then I did employed and unemployed. So this actually already matches the order that I the way I did that post hoc test. And I'm just going to spend more time cleaning it up than actually making the chart. So we're going to move employed and unemployed up here. We could add a label to that as well. I don't know, I think that's pretty clear what that is. So big, there we go. So this axis title is religion. But we definitely need one over here. What are these little numbers here? Okay, this is attitudes towards drugs. That is a super important label. If I click on this y-axis, it needs a line. Give me a line. Click on this one. Give me another line. Okay, so now I've got my lines on here. We're going to do the hard part, add the error bars. So I'm going to click on the first group, see how this is highlighted here. If you haven't done this in a while, we're going to hit Add Chart Element, Error Bars, More Error Bar Options, Custom, Specify, highlight going across because that's how it looked a second ago, delete the negative thing, highlight going across, make sure these 2 things match, and they do, hit OK. Now do the same thing for the other bars. Add chart element, error bars, more error bars, custom, specify, highlight, highlight. Okay. I think we're doing pretty good except for that ugly font. Okay. So let's change it to, oops, there we go. Times New Roman 10 to 12. Look at that. So why aren't we finding any differences? Well, look at these comparisons. Where's that interaction? Ooh, I bet it's like lower, higher, lower, higher, lower, higher. Ooh, flip. So that flipped thing here is probably where that interaction is coming from. Okay. Or if we rearrange the data, it's like high, high, low, high, and then high. All of these are roughly equal. So that's probably why we're getting this interaction. Remember, we'd also want to change this attitudes towards drugs, probably to the range of the data, which I think I said was 0 to 10. One more thing I can do before I paste this into Word so I don't have to deal with it on the Word side is click Format, drop down, No Outline. That'll actually get rid of that ugly border. And I'm going to stick my chart up here next to my output. And I could keep source formatting so that it's blue and orange if you're feeling blue and orangey today. This is auburn colors. Or I could change colors here and put it all in grayscale. Either way. Okay. Either way, I want you to give me a cleaned up graph so that I know you know how to clean the graph. Color, you can go bonker nuts on because if you can color it, that means that you can uncolor it. So, all that taken together, we started with power. What is ANCOVA? ANCOVA is like ANOVA++. We then did power. We talked about data screening. We worked through the whole analysis, post hoc tests. And then we ended with how to interpret everything and make a chart.